Across the vast American plains, the shift is instantaneous. The calm blue sky offers no warning before the atmosphere turns volatile. These are not breezes. They are atmospheric weapons. Gusts routinely exceed 100 miles per hour, capable of tearing apart modern, rigid structures.
When the snow arrives, visibility collapses instantly. The blizzard creates a disorienting, impenetrable wall where direction and daylight cease to exist.
The wind chill drags temperatures down far below zero. It is a deadly cold, routinely plunging 40 degrees below freezing, making every breath an effort. In this environment, shelter is not a question of comfort or convenience. It is the absolute defining boundary between enduring the storm and certain swift death.
They endured these lethal blizzards without steel, concrete, or modern insulation, a historical paradox born from ingenuity and necessity. These massive earthen structures housed up to 30 people, storing enough provisions to sustain them through 6 long months of unrelenting winter.
How did a building crafted primarily from soil survive winds capable of destroying modern timber and nail structures built just decades later?
The secret was not brute strength, but an intricate understanding of physics and aerodynamics, refined through generations of architectural intelligence.
This knowledge was forged in the specific environment of the Great Plains, a vast, open corridor of grassland spanning the heart of North America.
The summer months brought an almost unbearable heat. Temperatures routinely soared above 100 degrees Fahrenheit, turning the plains into a scorching furnace. The same regions endured brutal winters. Blizzards could strike suddenly, driving temperatures plummeting to 30 degrees below zero, bringing deadly conditions. This environment demanded resilience, encompassing a temperature variance of over 140 degrees Fahrenheit annually. Survival depended on adapting architecture to manage this immense swing. Beyond temperature, the wind was a relentless defining factor. It rarely stopped, ensuring that blizzards and dust storms were a common, terrifying seasonal threat.
Furthermore, traditional building materials were critically scarce. Trees grew only along riverbanks, and usable stone was almost non-existent across the immense grasslands. But the Great Plains housed 2 distinct approaches: the highly mobile bison hunters and the settled agricultural communities along the fertile Missouri River. These permanent villages belonged mainly to the Mandan, Hidatsa, Arikara, and Pawnee, tribes whose lives were rooted deeply in the rich soil of the river valleys. Unlike the nomads, these tribes needed permanent structures to protect their critical cultivated surpluses, huge stores of corn, beans, and squash, from winter depletion. Their villages required structures capable of enduring catastrophic wind loads, ensuring safety and survival during months of complete isolation within the frozen plains. The solution was ingenious: massive dome-shaped structures anchored to the earth itself, known today by their common name, the Earth Lodge. The first step in fortress-like construction was earthwork. The builders carefully excavated the lodge floors several feet below the natural grade. This shallow, insulated pit immediately stabilized the interior climate, offering a vital buffer against the relentless, extreme surface temperatures. Next, the core structural elements are raised. 4 massive, prepared cottonwood posts are sunk deeply into the earth at the lodge's exact center. These substantial support columns, thicker than any man, bear the immense weight of the roof structure that must withstand hurricane-force winds. Secured tightly in place, these central beams define the main support structure, locking the massive roof framework into a unified whole. A precise perimeter is established, using a ring of shorter, sturdy posts that define the essential structure of the outer wall. Long rafters are skillfully positioned, extending inward from the perimeter, creating a conical roof resting upon the primary central support beams. These vital structural poles ascend uniformly, converging toward the highest point, yet leaving a necessary circular aperture at the very peak. This carefully calculated gap is indispensable. It serves as the essential smoke hole,
providing ventilation for the hearth below. Insulation commences as thick bundles of pliable willow branches are expertly lashed and layered, forming the first protective skin over the conical frame.
The second insulating layer is created by thickly layered bundles of dried prairie grass, carefully woven and packed to trap maximum air.
The final critical stage of construction involves burying the entire structure under a mantle of heavy sod and loose earth, creating an impenetrable shell. This protective earthen covering is not thin. It is meticulously built up into a durable shell, often reaching several feet in thickness for maximum thermal mass. Once fully compacted and cured, the sheer weight of this earthen shell is staggering, bearing down on the timber frame with approximately 30 tons of pressure. To fully grasp this engineering feat, consider that 30 tons is equivalent to the weight of more than 2 fully loaded modern school buses. This massive earth lodge, a marvel of indigenous engineering, typically spanned 30 to 60 feet in diameter, built to withstand the worst blizzards. Rising impressively above the prairie, the center of the lodge often reached heights of 10 to 15 feet, providing crucial headroom and ventilation. Once fully layered with sod and earth, the earth lodge virtually vanished into the landscape, appearing from a distance as merely another grass-covered hill. Inside, the structure revealed a single expansive room, a communal space large enough to comfortably house an entire extended family throughout the harshest winters. Crucially, the women of the tribe served as the primary architects and builders, designing and erecting these immense protective homes for their people. The remarkable lifespan of these earth lodges typically ranged between 6 to 10 years before the inevitable necessity of a full rebuild arose. Cottonwood was highly accessible across the plains, yet its softness made it quickly susceptible to moisture, insects, and rapid decay. Given the vast tonnage of earth required for insulation, the inherent weakness of the cottonwood meant it could not sustain the full load indefinitely. The interior wood framework primarily functioned as temporary scaffolding, holding shape only until the heavy earthen shell fully settled and hardened. Ultimately, the true load-bearing, weather-deflecting element was not the wood beneath, but the incredibly thick, hardened earth itself. Once dried and settled, the thick sod covering fuses into a single, rigid shell. This remarkable structural integrity distributes the massive weight evenly, supporting the shelter. Harvesting began in the open prairie, where the short and mixed grasses provided the ideal soil composition. Carefully measured blocks were cut, ready for placement. The secret to the sod's resilience lies beneath the surface. These specific prairie grasses create root systems of extraordinary density, often reaching several feet deep. Buffalo grass, a keystone species, is vital. It spreads aggressively using rhizomes, creating a tough, tangled mat that locks the soil together into a single, cohesive block. This woven subterranean network acts as the ultimate organic reinforcement. The root matrix functions precisely like natural rebar, providing essential tensile strength to the earthen walls. This living layer of sod is vital. Its intricate root system binds the earth, preventing erosion and keeping the entire earthen shell intact against severe wind and rain. The careful engineering of the timber frame ensures the lodge can support enormous vertical loads, essential for surviving the immense weight of accumulated dense winter snow. The earth lodge design reveals a profound truth. The sod is not mere camouflage or insulation. It is the fundamental structural component. The sod is the lodge itself. To understand the brilliance of these ancient structures, we must consider modern physics. High-speed wind exerts immense, dynamic forces, capable of ripping modern roofs completely from their foundations. The critical danger is uplift. The rapid airflow creates low pressure above the structure, while the higher pressure inside pushes the roof upward, tearing it away from the walls. If poorly anchored, temporary shelters often succumb to the immense pressure. Entire roof sections can be ripped away instantly by the blizzard's fury. Sharp corners and flat vertical surfaces are vulnerable points. They interrupt the wind flow, generating chaotic turbulence and dangerously concentrating structural stress.
The brilliant geometry of the Earth Lodge systematically avoids these vulnerabilities. Its inherent shape is designed for optimal aerodynamic performance.
Its low circular dome profile minimizes exposure. The wind is simply deflected, presenting the smallest possible surface area to horizontal blizzard forces.
Crucially, the circular structure eliminates all sharp corners. Without these angular breaks, the devastating turbulence that destroys weaker buildings is never created. The dome-like design is crucial. Without flat planes or sharp corners, the powerful wind has no surface upon which to generate dangerous, destructive uplift suction. Engineered by instinct, the shelter directs gale force winds. The air flows smoothly over the curved surface, minimizing resistance, much like wind traveling harmlessly over a natural hill. By mimicking the contours of the land itself, the structure merges with the surrounding landscape. It becomes so integrated that it is nearly invisible to the powerful forces of the wind. This passive defense relies on more than clever shape. The sophisticated geometry required supplementation by immense mass, necessary to fight the sheer power of nature. 30 tons of earth, clay, and sod press relentlessly downward. This immense gravitational dead load ensures that the shelter remains anchored, immovable against any upward lift pressure. This tremendous dead load, the calculated weight of thousands of pounds of earth, sod, and clay, is defined by engineers as essential structural ballast. For the wind's powerful upward lift to succeed, it must first overcome the sheer inertia and monumental weight of the Earth itself, securing the dwelling firmly in place. In the end, the physics are absolute. Even the immense energy of a 100-mile-per-hour windstorm is insufficient to overcome the unwavering anchor of gravity. Modern engineering confirms this ancient strategy. Earth-sheltered homes consistently survive F3 and F4 tornadoes that completely level conventional frame structures nearby. However, the essential smoke hole poses a vulnerability. It is necessary for ventilation, but also allows precious heat to escape, and during the worst blizzards, snow to intrude. Yet, protection from the storm required ingenuity. The circular bullboat, typically a swift hide-covered vessel for river crossings, offered an unexpected solution. Its design was simple, a shallow, bowl-shaped structure. Crucially, its precise diameter was measured to perfectly fit the critical opening at the apex of the lodge. When the blizzard struck, every moment counted. The bullboat was quickly inverted and placed directly over the opening, transforming its function instantly. This simple action created an architectural plug. The hide, once wet and taut, formed a completely watertight and windproof seal against the extreme elements outside. This dual-purpose design, a means of transportation and a structural closure, exemplified the foundational ingenuity and resource efficiency required for survival on the plains. This durable, lightweight vessel, known as the bullboat, served not just for river travel, but crucially as the ultimate storm shutter for the lodge entrance. Shelter solved the immediate threat of wind, but the other relentless, silent killer of the Great Plains winter was the extreme, pervasive, numbing cold. Survival relied on understanding physics. The vast thickness of the earth walls acted as a reservoir, utilizing the crucial principle of thermal mass. As the main fire burns intensely, the dense earth surrounding the hearth and walls slowly begins to absorb and store this tremendous amount of thermal energy. Long after the flames die down, the thermal mass begins its true work, steadily radiating that stored heat back, keeping the inhabitants warm through the bitter night. This process of thermal lag buffers the space against rapid temperature swings, creating a critical margin of survival. Historical accounts confirm that due to this immense thermal mass, the interior remains remarkably warm well into the long winter night. We contrast thermal mass, which relies on slow movement, with modern insulation, which focuses on blocking heat movement entirely. The thick earth walls function precisely as a thermal battery, charging slowly during the day and reliably discharging warmth throughout the night.
Crucially, the semi-subterranean design of the structure taps directly into the consistent, stabilizing warmth of geothermal stability. The key insight lay in the ground itself. Below the dangerous frost line, the Earth maintains a remarkably constant, moderate temperature year-round. By excavating, builders minimized floor heat loss. The compact ground was not just a foundation, but a massive thermal heat reservoir protecting the occupants. The ingenious dome structure had a second purpose. Heavy snowfall did not shed instantly, but naturally accumulated, clinging to the rounded surface. This thick layer of trapped, still air within the snowpack acts as exceptional supplementary insulation, drastically reducing heat transfer from the lodge interior. As winter deepened and the storms intensified, the Earth Lodge became progressively more insulated, achieving peak thermal efficiency when it was needed most. Efficiency guided the design. The central fire pit provided vital direct heat, doubling as the community's primary cooking and light source. For sustained warmth through the brutal night, a supplementary method was employed. Dense stones were carefully heated until they radiated powerful, glowing energy. Using custom-crafted antler tools, these intensely hot stones were safely transferred from the main fire into a secondary, specialized warming pit. Once secured, these thermal batteries released a steady, unwavering source of radiant heat for many hours, requiring zero continuous wood fuel. Understanding thermal dynamics was crucial. Elevated sleeping platforms utilized rising warm air, strategically placing occupants in the shelter's warmest zone. The superior insulation of the Earth Lodge design ensured that every element minimized the expenditure of scarce and vital winter firewood. More than shelter, the lodge doubled as a sophisticated food storage system, utilizing integrated bell-shaped cache pits dug directly into the floor. These essential pits were meticulously lined with tightly woven willow branches and thick layers of dried grass, safeguarding the precious contents within. Functioning as underground vaults, these pits secured dried corn, beans, squash, and valuable seeds, ensuring survival through the lean winter months. The stable geothermal zone deep beneath the earth ensured these pits remained safely above freezing, keeping moisture low and crops viable all winter. These ingeniously designed subterranean storage pits ensured that vital grain supplies lasted reliably through the harshest winter months and well into the next growing season. For the Pawnee people, the Earth Lodge transcended shelter. It was understood as a profound sacred structure, literally a physical embodiment of the organized cosmos. The fundamental circular architecture was deliberate and profound, representing the infinite, unbroken boundary of the universe and the horizon. This crucial central smoke hole was not merely ventilation, it was the sacred symbolic path taken by Tierra, the creator god, entering the world. When sunlight descended through this opening, it represented the powerful, tangible presence of the divine, radiating warmth and blessing upon the dwelling. Parallel Earth-based designs, such as the deeply excavated pit house or the specialized subarctic collie, offered significant geothermal protection. Crucially, the collie incorporated a long, below-grade tunnel entrance. This structural feature functioned perfectly as a sophisticated cold trap. Moving east, the wigwam of the northeastern woodlands relied on portability and effective layering, using heavy birch bark and interwoven cattail mats. Interior insulation was key. Wigwams often used inner panels to establish crucial dead air spaces, sometimes packed densely with insulating dry moss. Despite regional variation, the core survival principles remained universal: maximize thermal mass, leverage Earth's stability, and rigorously minimize heat loss. By the late 19th century, the era of the communal Earth Lodge was tragically drawing to a close, leaving behind hollowed, silent structures. Forced relocation and restrictive reservation policies fractured long-held community structures, making the construction of permanent villages impossible. Without continuous practice and community focus, generations of precise knowledge, from ritual placement to material selection, began an inevitable, rapid decline.
Decades later, during the 1970s energy crisis, modern architects looked to indigenous ingenuity, rediscovering the superior thermal properties of earth sheltering. Using modern concrete and high-performance insulation, these contemporary structures harnessed the thermal mass of the Earth for unparalleled efficiency in heating and cooling. Modern geothermal architecture recognizes the profound wisdom of the ancient builders. The Earth acts as both an essential thermal shield and a reliable energy battery.
Their sophisticated knowledge was rooted in relentless, detailed observation, studying wind paths, assessing root structure strength, and tracking the precise timing of natural decay. Specific ancestral details, the perfect proportions, precise building timing, and sacred rituals were tragically lost because this complex engineering existed only in practice, never in writing.
What truly remains is the undeniable proof of its efficacy. Generations of families successfully enduring the continent's most unforgiving blizzards and harshest winter climates.
The Earth Lodge was not mere shelter, but a sophisticated, multifunctional system, brilliantly engineered to solve overlapping challenges of heating, ventilation, security, and storage simultaneously. This profound architecture achieved its resilience solely using materials sourced immediately from the surrounding landscape, a testament to resourcefulness.
The success of the design lay in humility, understanding that working with the immense, uncontrollable forces of nature was the only path to survival.
Gravity anchored the structure against punishing winds, while significant thermal mass smoothed out the brutal temperature spikes of the high desert winter. The final lesson: true survival demands profound environmental understanding, allowing them to transform every apparent limitation into a strategic, life-sustaining alliance.